And in terms of looking at what regulates methane consumption, to my knowledge, we're the only ones doing those sorts of experiments. Like, what regulates the ability of the microbial community to consume methane and keep it out of the atmosphere? I can't tell you why it isn't being done. I really don't know. I think that I mentioned, maybe it was last week, that, unlike oil, methane's invisible. It's not one of those things that you tend to think about. I mean, every previous oil spill that has ever happened, there've been, leaky wells and the Ixtoc blowout in '79. When it's a cargo ship filled with oil that leaks, measuring just the oil is okay. But with Ixtoc, they didn't measure dissolved gases, and with this. When you hear the BP spill, do you ever hear methane spill? It's an oil spill. Methane is just out of sight, out of mind, but it's inherently a critical component of this reservoir. And it's coming out in masses that are, not that different from the oil, about a third as much methane as oil. So you can't really think about, this is a hydrocarbon spill. That's how I've started that's what I use to describe it. It's not an oil spill, it's a hydrocarbon spill. And when you think about it in that context, then it becomes important to quantify all aspects of that spill, and that includes the dissolved hydrocarbon gases like methane, ethane, propane, etc.
If the methane is trapped in deep water, once you reach a saturation point, at which point it does go into the atmosphere?
The way it works out, the deep water has a phenomenal capacity to hold methane. The saturated value at 4 degrees C and 1,500 meters, or 155 bars of pressure, is around 250 millimoles per liter. That's a lot of gas. And the concentrations, the highest concentrations that have been seen out there have been about a millimole per liter. Which is still a lot, but it's not 250 millimoles per liter. So, in fact, the capacity of the water is there's way more, and that's why the methane goes into solution, because it's really hard to saturate it at that depth. And remember, the water's moving. So if it was just water, fixed water sitting over the wellhead, absolutely, it would ultimately become saturated, but it's not. It's dynamic. The water's moving. So you're never putting the gas is always going into a different body of water. So there's always a capacity to put more gas in the water. Yeah, and they're consuming about 1 to 5% per day of the standing stock of gas, which is oddly enough pretty normal. Go ahead. You're good.
Yeah, Phil Cato with that motion again. So I'm feeling your frustration with the lack of sampling, and I'm wondering, who are the government agencies that are supposed to be attending to this? I mean, it seems to me we have a once-in-a-lifetime, once-in-a-century, once-in-a-Earth history catastrophe that ought to have all hands on deck, maximum scientific effort, and it's not happening. So who do we point the finger at? Well, that's a loaded question.
It's definitely a loaded question, and I'm not really going to answer it. But I will tell you a couple of things. The National Science Foundation has supported my work on methane dynamics out there, and John Kessler's, and I think Rich Camilli's as well. NOAA has also funded some of the work that I've done out there. In terms of whose mandate it is, I think that this certainly should have been included in the list of absolute, if there is a list somewhere of things that you absolutely have to measure with respect to this oil spill, then my list would include the oil fraction, and that would include all of the oil, all of the hydrocarbons. So the, alkanes, low molecular weight, high molecular weight, aromatic and straight chain. It would include the dissolved hydrocarbon gases, methane up to pentane. And it would include things like all the various components of the dispersant and their derivatives, and then just basic biological and chemical parameters like dissolved oxygen and temperature, salinity, etc. You sort of have to. I think the reason that methane hasn't been measured is that, again, it goes back to this focus on oil and this visible entity, and it's an oil spill. It's not a hydrocarbon spill. It's an oil spill, and it's a mindset. And I think that in this case, it was just simply an oversight, and people never, other than people who work on methane and are fixated on methane and spend a lot of time thinking about methane, like me, methane probably was not very high on the priority list, and that really shouldn't. I guess it surprises me because I have worked on methane for a long time, but I'm not surprised that the focus on this spill was oil, because that's the focus of every single oil spill ever has been on the oil. Gas just gets overlooked. But in terms of mandates of who does it, I mean, I think it should have been on that absolute must-measure list, and it still doesn't appear to be on that absolute must-measure list, and that in my book is a big problem.
But how many research vessels are involved in the measurement program at the present time? Is it a few, 2 or 3, or?
I honestly haven't looked on the website to see how many vessels are out there right now. I know that there are a couple of natural resource damage assessment cruises that are underway right now. I don't know of any of those vessels that are measuring methane. I don't think they are. But like I said, we've gotten samples from a variety of different researchers to do methane concentration measurements. And we're going back out in August, September, and we'll be getting more samples, and I suspect we'll get samples before those cruises. It really isn't. There have been vessels of opportunity out there where more methane samples could have been collected. For some reason or another, that it just didn't happen, and part of it is really, it's an issue of everything that we do as scientists is an issue of time and money and personnel. And right now my lab is pretty maxed out in terms of I'd have to hire 2 or 3 more people to process any more samples than we're sampling. And I'm sure I speak for everybody that's associated with that's doing work related to this oil spill. Everybody has more samples that they can possibly deal with. And there aren't that many groups really that do methane dynamics in the open ocean water column. They're just there's a handful of groups in the country that do that sort of work. I mean, I can think of maybe 5 or 6, and that's not a lot when you think about it. But that doesn't mean it wasn't possible. I think it was certainly possible, and we're basically going all out, processing as many samples as we can possibly process. And I've yet to turn down a sample that I've been offered, despite the fact that we're way past capacity. We're just stacking them up and measuring them as fast as we can.
Mm-hmm. Okay, thanks.
One more question.
From the phone, please?
Yeah, go ahead.
Hi. Lisa Duchesne, freelance right now for Seafood Business Magazine. And if I may backtrack, I want to get some clarity on the amount of methane, or the proportion, I should say, of methane. What I've read, if you can confirm for me, that gas is making up about 40% of the hydrocarbons found. It makes up 40% of the hydrocarbons found in this reservoir that was tapped by Deepwater Horizon, and methane is 95% of that gas. Is that correct proportion?
The first number, 40%, is right on target. That's the gas fraction, as documented by the petroleum engineers when they first did the reservoir fluid testing. The fraction of methane, I have yet to get confirmation from anybody anywhere, and I've asked everybody everywhere as to what the C1 to C5 composition is in the Macondo reservoir. That means that I can't tell you what percentage methane it is. But I can tell you what the percentage methane is from the Mississippi Canyon 118 reservoir, which is 8 miles to the north of MC252, and that's 95% methane, 3% ethane, 1% propane, 0.7% butane, and 0.3% pentane.